In this video, we'll look at integrating a power of sine or cosine, and the example I've chosen is the integral of sine to the fifth of 2 times x. The first observation to make is that the power, 5, is an odd degree. When I have an odd power of sine, what I will do is separate it into an even power and then one extra factor. So I've taken it to be sine to the fourth times sine of 2x. The even portion here we will convert to cosine squared in a moment. This extra one here that I've pulled off to the side, I'm going to save as a derivative of cosine for a substitution. In order to convert this factor first, what I'm going to need to do is convert it to cosine squared, and I'll write it as sine squared squared. So sine to the fourth is sine squared and then squared again. I've still got my extra factor of sine here separated to the side. I'm now going to convert this sine squared to cosine squared using the Pythagorean identity. So when I rewrite it, I'll have 1 minus cosine squared of 2x, and I square that, and I still have my saved factor of sine of 2x on the side. I'm going to do a substitution. I'm going to let u be the cosine of 2x because its derivative is roughly here as a factor in my expression. When I take the derivative of u, however, I'll get a factor of minus 2 times sine of 2x. And so if I solve for sine of 2x, I'll have minus 1/2 du is sine of 2x dx. We can carry out the substitution now. It's going to be a minus 1/2 from the differential. That will be minus 1/2 du will take care of the sine of 2x dx that I saved. And then inside the brackets I had 1 minus cosine squared, so now it's going to be 1 minus u squared. And remember, the entire thing was squared as well because it came from that fourth power, so this is now squared. What we do next is just expand this expression out, and we're integrating a polynomial in u. So expanding everything out, I'll have 1. The middle term will be minus 2 times u squared, so 2 of the u squared terms. And then when I multiply the u squares together, I'll have u to the fourth, and it'll be positive now, so plus u to the fourth. We now integrate each of these terms one by one. I have a factor of minus 1/2. If I integrate 1, I get u. If I integrate 2u squared, I get 2u cubed over 3. And then u to the fourth becomes u to the fifth over 5. And finally, all I have to do is back substitute and replace u with cosine of 2x in each term. So I'll have minus 1/2 cosine of 2x. I'll distribute the minus 1/2 through onto the 2/3, so I'll have positive 1/3 cosine of 2x. And then finally distributing the minus 1/2 through to the 1/5, I'll have minus 2/5 cosine of 2x to the fifth power. So let's just review what we did. When I had this odd power of sine, I saved as many even powers as I could for converting to cosine, and I saved one extra factor of sine for the substitution. I converted all of those to cosine. I took u to involve the cosine, and its derivative was right there for the substitution, and essentially what we had was some big polynomial that had to be integrated term by term, which we did, and then finally back substituted and put cosine back in.